Welcome back. Today we will discuss about all the different types of displacement time graphs. So let us first look at what a distance time graph actually in general. We plot the independent variable, in this case time, on the x-axis and the dependent variable, here the distance, on the y-axis. And by plotting the positions at corresponding time, we can see the variation of distance or displacement over time. Now, we have distance on y-axis and time on x. So the slope of the graph is the distance traveled per unit time, which we define as speed. In case of a displacement time graph, we call this slope the velocity. Now start looking at some of the graphs. The simplest one is a straight line parallel to x-axis. And as you can see, the displacement doesn't change over time. So we say the object is at rest. You can also see that the slope of the graph is 0, and hence the speed is also 0, which is quite evident as the distance or the position of the object is not changing over time. The other case when we get a straight line in distance time graph is when the velocity is constant. Then we get a graph where the distance changes linearly over time. Both of these are examples of uniform motion. For a body to be in uniform motion, it should either be at rest or moving with a constant speed. In other words, the acceleration should be 0. We get straight lines on displacement time graph whenever the acceleration is 0. Now let's look at some of the graphs where we have the same initial position but the first graph is for a velocity of 4 meters per second. Now we add the new blue line which we get by taking velocity as 7 meters per second with the same starting point. We can clearly see that the lines get steeper as the velocity increases. So the faster the object moves, the steeper the graph will be. Now in this next graph, we have the starting position or the initial displacement as negative, but the line is upwards. This occurs when the velocity is in the opposite direction to the initial displacement or the initial position with respect to a certain reference. For example, like you can say, you are in a running race where you have to stay behind a starting line. If we consider the starting point, the starting line as the 0 displacement point, your initial position is in the opposite direction to your target goal. So you can say that the initial position is negative, but since you are going in the direction which you want, you can consider that as the positive direction, and then in that case the velocity will become positive with an initial negative displacement. Now let's some of the graphs for non-uniform. In case of a non-uniform motion, the speed or the velocity of the object is varying over time. So the first kind for a non-uniform motion could be an accelerated motion. In this kind of process, the velocity of the object increases over time. The displacement time graph of such a motion will look something like this, where the graph is curved upwards. A displacement time graph which is curved upwards indicates an accelerated motion. And the second type of non-uniform motion is deceleration. It can also be called as retardation. In such motions, the velocity of the object is decreasing. So a standard graph of such a decelerated motion is as shown here. where we can see that the graph gradually curves downwards. A downwards curving graph for a displacement time graph indicates that the object is decelerating, or its acceleration is in the direction opposite to the velocity. Now let us consider a very common example that your accelerate start. So how will the graph for such a motion look like? So when we start the car, like we are starting from zero velocity, right? So, and we can assume that the acceleration is constant for some time. In that case, you get a graph something like this. So we have already said that if the graph is curving upwards, it indicates a positive acceleration. That means your velocity is increasing. And how do we know that the velocity is initially zero? For that, like, you have to look at the starting point. If we look at the point where we start, we see that the graph starts out very flat. So at that point, the slope of the graph is actually zero. So we already said that the slope of a displacement time graph gives its velocity. That means the initial velocity in this case is zero, but it is gradually increasing as we are in an accelerated motion. A common example of a graph obtaining like this will be for an object falling from a height. So in that case, the initial position can be considered as positive as the object is initially located at a height. But then it is falling downwards. So we consider acceleration to be negative or in the opposite direction. So in that case, when an object falls from a height downwards, we can get a graph which resembles this. One other kind of non-uniform motion, one of the most common kind, it is for oscillations. Oscillations or vibrations are very common. We can see it in the vibration of strings of music instruments, or any kind of random motions like pendulums, springs, etc. etc. So the displacement time graph of an oscillation will look something like this. The standard term for such graphs is we call it as sinusoidal, as they vary as a function of a sine, a mathematical function of sines and cosines. So that's about it for this video. See you